Hello all, welcome to Chapter 4, Consumer Equilibrium and Market Demand. This class lecture kind of should be a little on short side, but we're going to be running through a lot of graphs with just changes in numbers. So I'll try to leave it on for a little bit, or you can slow it down and kind of advance forward to read what's on the graph as we go. Okay, so once again, the learning objectives, feel free to read these on your own. And what we're trying to accomplish here today in this chapter. Okay, so quotes for the chapter. Character consists of what you do on the third and fourth try, and the most difficult thing is the decision to act. The rest is merely tenacity. You know, I like that first quote. I haven't been too fond of the chapter quotes and thought about deleting them out, but I kind of like that first one because I always think about the things that I know in life, right? And so this really ties into education and studying and how you learn. And I've learned for myself anyway, and I think my kids would attest to this as well if I asked them, that a lot of times what you learn and you know the best is what you failed at the most, right? So if things come easy to you, there's a benefit to that, but you might not learn it as completely as when things come hard. And so when I think about something like projects or doing homework, I think, okay, so it's a challenge, I'm getting this done. But really it's about learning from your mistakes, right? And so for myself, I had a particular car problem a while back that I was working on, and it took me 14 months to finally figure out that car problem. It ended up being in the intake manifold gasket. It was leaking, and it was not a visible leak, and didn't even really leak enough on a pressure test to have caused the problem that it was causing. But anyway, it ended up causing a pretty bad problem, and it took me forever, right? 14, 15 months to get this problem solved. But by the time it was done, I knew the engine on that truck inside and out, right? I knew the emission system. I knew the way that car breathed and what was going on, because I spent so much friggin' time on the internet talking to mechanics, talking to dealership, service technicians from the factory, trying to figure out what was going on with this vehicle and why it wouldn't pass smog. And so I think it's always important to say that, you know, it's through our failures and adapting to our failures that we really learn and grow. And so, you know, I left that quote in. So we're back to consumer equilibrium. So last time we talked about in chapter 3 that we really didn't call it the demand curve, but that's where we're heading with this, right? We talked about indifference curves and isoquants. We talked about the budget constraint and the fact that you're going to choose based on that budget constraint. So now we're really getting into how does the consumer make that decision to choose, right? And what's it look like mathematically, and what does it look like on the graph? And I'm going to be honest, when it comes to the final exam questions, maybe not the problem sets because they can be a little harder, but when it comes to exam, I'm probably not as concerned with the math in this section as I am the final result and kind of the intuition behind it, which is we want to know why consumers make decisions, right? And, you know, we'll just go on from there. Oh, let me take a step back on that actually really quick. So what this equation is just saying is that the marginal rate of substitution is equivalent to the marginal utility of hamburgers divided by the marginal utility of tacos, which is also equivalent to the change in the quantity of tacos divided by the change in the quantity of hamburgers, which is also equal to the price of the hamburger divided by the price of taco. And that's going to happen when we're at our equilibrium, right? All of these things come together in perfection. And so what we need to determine is when utility is at its peak. And utility, remember, is at its peak when marginal utility is equal to 0 on the last dollar spent, or when we're at the top of total utility, right? And so we can define this mathematically as the marginal utility of hamburgers divided by the price of those hamburgers. One way of thinking about that is this is the per dollar utility of hamburgers. And we're going to say when it's equal to the per dollar marginal utility of tacos, right? When these two are equivalent, then we're at the peak amount of marginal utility that we can gain on that last dollar spent, right? And so if we had an infinite budget, then we would keep consuming those hamburgers and tacos until marginal utility went to 0. And the second it went one step past 0 to negative, that's where we would stop. But because we don't have an infinite amount of income, we're going to stop when these are as close to equal as possible. They might be at 0. They might be positive of 0, right? In fact, normally they will be if we have a budget constraint. So this is just the back to the graph with the ISO cost, the ISO quants and ISO utility curves. And this is our budget constraint. So the budget constraint is the thick blue line going from 10 tacos to 4 hamburgers per week. And remember, with the cost structure, 50 cents of tacos and $1.25 hamburgers, that points A, C, D, well, A and D are going to be equivalent utility, right? So first things first, just look at the graph. So obviously, if our budget constraint is here, can we get out here on this curve where it looks like we're at what, 400 utility on the ISO cost curve, or yeah, ISO utility curve 400? We don't have enough money. We can't consume past our budget. So we can only consume on this graph point C or point A. Point D is also outside of our budget process, right? So if that's the case, we can consume anything on the line for I1 equal to 100 until it hits the blue line and goes out. We can't go to the right of the blue line. But that's a lower utility curve. We're getting less utility. We want to move to the one with the A and the D. And there's only one point where that curve is equivalent to the budget constraint. That's at point A, right? So that's our limitation. So remember, we can't consume past the budget constraint. And our goal is to consume the highest point that we possibly can on an indifference curve, right? Where we can still afford it. So for this, it's point A. And so that's all we're saying in this slide is that points B and D exceed the budget. They're not affordable. Point C is affordable, but it's not utility maximizing because we could have had more happiness by just going up to indifference curve 2. So if we look at the impact of three separate price levels for $5, $1.25, and $1 on this consumer's weekly purchase price of hot dogs. So what we're really going to do is kind of play with the numbers and see what happens, right? So here we've got price of hamburgers, $1.25, price of tacos, 50 cents, income's $5. You're going to be able to purchase 5 tacos, 2 hamburgers, right? That's what we said last lecture, where we are. So what happens if we decrease the price of the hamburger to $1? So if the hamburger goes to $1, we can now shift out this curve where we go E is at 10, right? 10 tacos, because the price of tacos didn't change, but now we can consume more. We can consume 5 burgers. And so in that case, we might be able to attain a new indifference curve. And in this case, we are, and it's further from the origin. So therefore it makes us happier. And we've got a new point where we could get 4 tacos and 3 burgers. And we're going to be happier at that point. That's the argument, at least, than purchasing at point A, right? Because at point A, we're not as happy. What would happen if the price increased? Then we get this new blue line. So if the price of a hamburger becomes $5, then you can only get 1 to make you happy. And there's only one point on this indifference curve 1 that passes, that's point C, where we're going to purchase half a hamburger and a little over 5 tacos. Now, I want to point out, this is math, but it's not realistic. How many hamburger places will let you buy half a hamburger? Very few. So this consumer might be in the position where they say, look, I'm only going to buy the 5 tacos. I'm not going to buy a burger because I can't afford the burger, right? In all honesty, this consumer, if they have to buy in whole units, they can't afford it. So they might as well. Their real decision is, do I make 1 burger or do I buy 10 tacos? And if that's their decision, they need to look at which of those would have an indifference curve that would make them happier, right? And we don't know that because we don't have all of the indifference curves available. But just looking at the shape of these indifference curves, it's unlikely. So this line C to A to B forms the basis of a consumer demand schedule. This is how we can show what the demand curve for these two goods would look like over time. And what we see is there is a general downward slope. So this demand schedule shows us how a consumer responds to a change in the price of hamburgers, right? So technically, the line CAB is just a price consumption curve, right? It's not truly the demand curve yet, but it's a price consumption curve. And it tells us as the price of hamburgers pays, we're utility maximizing. So as the price changes and we go from expensive to cheaper, we want to buy more. So at this point in the course, we have 4 economic laws. We talked about the law of diminishing marginal utility last time. That means the more you consume, the less happiness you get. We talked about Engel's law, which is as income goes up, you don't tend to spend as much on food, right? I'm probably quoting that wrong. Anyway, it is what it is. But anyway, and then we know that incentives matter, right? More is better than less. And we also know, and that's not really a law, but textbook's throwing it in there. And then we know the law of demand. As price increases, quantity demanded decreases. And as price goes down, you want to buy more. So if we look at the price of steak in cents per pound and the quantity consumed, and this is some real world data, let's assume. Don't know where the publisher got this, but you could actually think we could generate that on Fred, couldn't we? Anyway, but what we see is the relationship between price and quantities. And what we can see is, as a generality, as the price, 5 cents per pound or $5 per pound, sorry, 500 cents per pound, so $5 a pound. As the price goes up, people don't want to buy as much when we're at these high prices. As price goes down, people want to buy more, right? And so this is a general tendency. And this data would track a bunch of different consumers. Could have done it through a survey as well. So another example with budgets. So Betty and Wilma want to buy t-shirts and shoes. Betty has a budget of 600. Wilma has a budget of 1,200. These must be some high-end shirts and shoes. At least for my lifestyle, I know people spend a lot on shoes. I personally can't stand the fact that as I've aged, I'm now spending $120 to $40 on shoes, which is crazy. Back when I was younger, I used to I set price limit, I wouldn't spend more than $40 on a pair of shoes. But anyway, it is what it is. And same with the t-shirts. I don't know where they're getting these shirts, but whatever. So we've got this. So the idea is we're going to use the indifference curve analysis to determine the price for t-shirts and for shoes. For which commodity can you derive a demand curve, and then derive the curve for Betty and Wilma. And then we're finally going to derive a market demand curve, assuming that they're the only 2 customers in this economy. So hey, just do this along the way. So we have 2 different budgets with different prices we can say on t-shirts. And so we know for Betty, a price of 20 t-shirts and 20 shoes. So if we imagine it was $1 and $1, it isn't. So let's see, Betty, let's go back. Betty has $600. So if Betty has $600 to spend, then we can take that 600 and divide by 20 just to figure out what the price is. Let me fire up my calculator real quick, because less likely to make a mistake and lead yesterday. So if we do 600 divided by 20, then we know that this represents a price of 30 for the t-shirts. Likewise, at $40, or sorry, at 40 t-shirts, they're 15 a t-shirt, right? And we can do the same analysis for the price of shoes. And we say that $600 divided by 20 pairs of shoes is $30 for a pair of shoes, right? So what we're really doing though is we're looking at t-shirts, right? Changing the price of t-shirts. We're going to decrease the price of t-shirts, which allows us to buy more. And so what we can see, we can do that tracking again and look at that curve. The same analysis can occur on Wilma's side, but remember this time it's 1,200, right? So if we go with our original numbers, then we can do 30 times 40, and that equals to 1,200, right? The prices are the same. So we're doing this $30 price. And what did we say the other one was? $15 price. So we're halving the price. So So, oh, sorry, that backed me out of the show, folks. Let's make sure. I think we're still good, but let me set up the share again. Make sure we're sharing the right thing. Good. Okay. And let's fast forward. Not a huge fan of PowerPoint. I think you guys have figured that out. I normally like a whiteboard or a chalkboard, but it's harder to see. So we could derive this whole table out with the information on the other side, and we can say for a quantity of shirts, what the price was, for the pair of shoes, what the price is, and we can fill out this whole graph. So let's go forward and backwards, and we'll add that data in. So remember, we said that at 20 t-shirts, then the price was going to be 30. Okay, so we go backwards. And here, so 20, then 30. And then when the price went to 15, we could buy 40. And we know this price again was 30 and 15 as well. And we'll go look at that number. And then we know for the shoes, it was going to be 20 shoes, regardless, was the most. And the price of the shoes was going to be 30. And we'll have to look, but let's go to the next one. So okay, so I'm just looking back at the previous slide. Let me do that for you guys so you can see. Wrong way. Next slide. And so with Wilma, we know that it was 40 and 80 then. And for the shoes for Wilma, we're looking at 40 shoes divided by that 1,200. It should be 30, right? Yeah, $30 per pair of shoes. Okay, go previous. Started with 40 and now we end up with 80. And so on this next graph, we could actually draw out demand curves. So let's see whether I can figure out how to do this on PowerPoint. I might not be able to be this tech savvy, folks, so just bear with me for a second. Okay, so I'm not going to put the actual numbers, but we know for Betty and for Wilma, well, let me draw one of them. So let's do the next one. We're also going to get a downward sloping curve. It's just going to be a little further out, right? And then we can do another one for the market. And we would label these curves with price on the vertical axis. And let me see where I can do that. Insert. So let me insert that, but not getting. Oh, I found the summation one. Well, regardless, the vertical axis would have a P for price. The horizontal would have a Q for quantity. And we're going to get that price and quantity for that where we do the labeling on our prior graph, right? And so we'll get that when the price of t-shirts is 30, the quantity is 20 for Betty. When the price of t-shirts drops to 15, the quantity goes to 40, right? And so we're moving down that curve and out and receiving more, right? So anyway, we'll leave that alone since I can't add more. But once again, price on the vertical axis and quantity on horizontal, and the data just comes from the prior page. So I'll leave that as an exercise for you guys to do on your own since I can't make PowerPoint do it today. Okay, so another example, what happens if we change the income? Now you just have more money, right? So price hamburgers still $1.25, price tacos 50 cents, income's $5. That's our original equilibrium at point A. 5 tacos, 2 hamburgers. Okay. We're going to assume that both hamburgers and tacos are what are called normal goods. And so that means as income increases for a normal good, you want to purchase more, right? So that isn't always the case. We could make an argument that if you became wealthy enough, maybe you would substitute out hamburgers for steak and substitute out tacos for, I have no clue, fajitas, right? Both of which are more expensive. But in this case, we're going to say they're normal. There's no substitution of goods happening. They're not what's called an inferior good, which means as you make more, you actually buy less of it. So what happens when we have this increased money? We shift out the budget line to represent the $6 we now have. We also get to move to a higher indifference curve as one's available. And what we see is we go from original equilibrium at A up to original equilibrium at B from increasing that income. What happens if we, once again, were to increase, right? So our budget line for $8, we can now consume more. But what we're arguing here is that tacos at that shift became an inferior good. And the reason being, like I said before, because your income increased to 8 a week, you decided, tacos, who wants tacos? I want to upgrade to something else. So you're going to get less tacos and you're going to substitute out more hamburgers because in this example, you're preferring the hamburgers. So as your income increased, your taco consumption fell. And that's how we notice when something is an inferior good. So the angle curve for hamburgers, if we assume that it's a normal good, then we're going to look like this. And we end up with, as income goes up, hamburger consumption goes up. If it's an inferior good, then we end up seeing that as income goes up, we initially consume more and then we'll start consuming less as income climbs, right? In fact, it's really becoming an inferior good from B to C. So the market demand curve for a particular product can be seen as the horizontal summation of all of the demand schedules for all consumers in the marketplace. It's just additive, right? So we're just moving the curve out further and further as we add consumers. So if we have our Paula's demand curve for hamburgers, so price is $1.50, she wants 2. Beth, price is $1.50, she wants 1. Then if they consist of the marketplace, then at a price of $1.50, we're now wanting 3 hamburgers in the marketplace. So what influences a demand curve? What influences your demand preferences? One is the price, is the own price of the good. The other is going to be other goods, right? So the quantity demanded is reflected in the price itself, not in the demand curve. Let's start changing this along the way, which is we've got 2 things going on. We have your quantity demanded, which represents your actual demand, right? What you want. Then we have the demand curve, which is all of the prices and the quantities demanded at each price. So then we have other prices can influence that. So one way to think about that is if you're buying hamburger, and let's say you're just buying the patties, what happens to your desire for hamburgers as the price of hamburger buns goes up and down? Or better yet, what happens to your demand for hamburger buns as the price of hamburger meat goes up or down, right? The more hamburger meat goes down in price, the more hamburger buns we would expect to see. And we call this substitution. We can also talk about goods being related, right? So maybe you're substituting one good for another, or sorry, complements is what we were talking about with hamburgers and hamburger buns, where they complement each other. But with substitutes, maybe hamburgers are a substitute for another good, right? In this case, we've been using tacos as our example. So you substitute out a hamburger for another good for a taco at some relationship. Your income and wealth influence demand, and then your tastes and preferences. And tastes and preferences can be informed by lots of things: advertising, health, nutrition, food safety, population, your peers, right? What people are consuming around you influences what you want to buy. So all those things can happen. What I like to say is at the end of the day, the only things that can really shift the demand curve, all of these items for the most part fall under the bracket of preferences, right? So your preferences go up or down based on your wealth, based on your taste, based on other prices of goods, right? They lead you to prefer things more or less. And then from a market perspective, it's not just preferences, but it's also the number of consumers. The more consumers, the more the market demand. The less consumers, the less the market demand. So when discussing events in the marketplace, economists use specific terms to distinguish between a movement along a demand curve and a shift in a demand curve. A movement along a demand curve is referred to as a change in the quantity demanded, and that is just based on the price. As price goes up and down, you move up and down that curve. A shift is related to a change in actual demand for the good. And so when we move from curve B1 to curve B2, we are shifting along that curve, and we can do that by saying that at a price of A, if we hold that constant, we're going to actually purchase more on this D2 curve than we did on the D1 curve. A movement from point A to point B is just a change in the quantity demanded, and that happened because the price went down. So an important extension of the market demand curve is the concept of a consumer surplus, which is a way economists think about deriving the welfare or well-being of customers in the marketplace. The demand curve tells us the willingness of a consumer to pay for certain things and for quantities at a certain price. The difference between willingness to pay and the amount actually paid is just the consumer surplus. And the best way to view consumer surplus is really graphically, and then use that graph to calculate. So the other idea is that we can have, the idea of extending that consumer surplus argument is that consumers derive well-being from the good, and consumers, anyway, we'll take a step back. Consumer surplus just tells us how much better off you are if you're at a different point on the graph, if you have different willingness to pay than the marketplace. It'll be easier when we get to a graph. So let you guys read this, and I want to get to the graph and actually show you it. So here we've got a consumer. Consumer is in this area A, B, and C. So if the price is $6, any of these consumers up here that would have been willing to pay more for some quantity are getting a better price because they're getting market price 6. So the area of this triangle A, B, and C determines the amount of consumer surplus. And so we know that these people got to benefit. We just calculate this area. So we take 11 minus 6, which is 5, and we multiply it by the quantity. So 5 times 5 is 25, and we divide in half for the area of the triangle. So 12.5 is the actual consumer surplus. If the price went down to $5, then we'd have a $6 change in price here, and we'd have 6 here, and it's 6 times 6 is 36, divide in half, and we get 18, right? So we went from 12.5 to 18 consumer surplus. As price went down, there's more consumer surplus. So the gain in consumer surplus from one point to the other is just the area A, B, C, E, right? That shows us that the difference between consumer surpluses is really the gain, right? And so we can calculate that out from 12.5 to 18, and we can say 5.5 would have been the actual consumer surplus. This consumer surplus concept, and there's an idea called producer surplus that works on the supply side that we'll look at later the following week, really underline the way that economists do welfare analysis. So when we start talking about government intervention in marketplaces, we're going to be looking at consumer and producer surplus changes to tell us what's happening in the marketplace. So thanks for listening in on this lecture, and I hope it was helpful. So everyone, just have a good day, and thanks for coming.